I know Rob's gonna rap.
Party up, people. Party up.
Way to go.
Get all fat and sassy. It's Thanksgiving week.
Come on.
That's right. We're going to get a lot
Come
fatter.
on, Russell. What's up with that, man?
No, hey, Rob, that was PHAT. I don't want us getting fat.
Yeah, I know. I'm not fat at all.
Oh, Bill missed it. I'm sure.
Oh my
The
God.
worst timing in the world. We have Bill. I mean, that was for Bill, but hey, IoT Coffee Talk people.
All right.
Welcome.
Thank you.
We give thanks.
Yeah, Thanksgiving. This is a Thanksgiving episode, and it's a sponsored episode. And we heartfelt thanks to the folks at EMQ Technologies for making a donation.
Thank you.
A donation to elevate our kids, okay? And as all of you should know, the purpose of Elevate Our Kids is to bridge the digital equity divide for kids K through 12 in underserved and distressed communities. And so one of the things that we're going to try to do is with the donation that was made, have been made thus far, because we have a donation drive going on. We're trying to hit 25,000 folks. Is to support the town or the city, which used to be the capital of Hawaii, Lahaina in Maui. And so some of you might recall they had that tragic fire. So we're working diligently to figure out how we can place some donation funds there to help that community. So those of you out there who are generous, like the folks at EMQ that would like to help out, and trust me, it feels good, then please donate. Go to www.elevateourkids.org. And if you aren't into charity, but you're into fashion, right here,
Merch.
you know what I'm saying?
Get some merch.
And Stephanie, tell our man over there, Russell, I'm sorry.
Tongue-tied this
Ernest
morning.
Russell. Welcome, by the way, and we'll give you a chance to introduce yourself, but we know that you want a shirt. So, Stephanie.
Yes.
You'll get that, yeah. Yes, so I will send you the link and anyone else, and we also have that posted on our LinkedIn page. So it's on essentially my Etsy shop, but that's where we have them. I will be adding some hoodies soon. I got to redesign them, but I'm going to do a black hoodie with the white IoT lettering and then a white hoodie with the black. So we're going to have both, depending on what your preference is. So stay tuned for the winter hoodies.
Nice.
Be off the hook. It's going to be ridiculous.
Awesome. Stephanie, are you not going to make a burnt orange hoodie?
Absolutely not,
Pumpkin
Rob.
spice hoodie.
Oh, Rob, who are you guys playing Thanksgiving week?
I don't know. Do we still play A&M?
No, that's not happening. We're playing LSU.
Oh, wow. I have no idea. I'm clueless at this point. I'm so out of touch.
Yeah, Rob was the one who gave the $100 million to buy out the contract, so he's a little upset.
Obviously, I'm in the wrong business. I should be a washed-up loser coach in college.
At $27,000 a day for the next 4 years, I'd love to.
I had no idea that I've known from the past that oftentimes a college football coach at the major state university might be the highest paid person in the government of that state. I remember learning that a million years ago as a kid. I was like, they made more than the governor? Wow. It's like, well, it's because UT football is more important to Texas than the governor. And so, but now
Sure.
who knew that, at another tier, a school like A&M would have such a big budget for a college coach. So I've never had any idea.
Number one engineering, number one law school. Come on, dude. But the crazy thing is the day before that was announced, is they're zooming in on the field. My son was there at the game, and there's like $167 million donation to the Association of Former Students, which is our alumni. And then the next day, it's like he's let go, and I'm like, well, they just made up for that. But geez, can that money be going to some kids' scholarships and some other things? It's just
That's right.
Yeah.
Get those laptops, get that cellular connection to those kids, underserved families, under-resourced communities. Get those kids connected. Let's narrow the digital divide.
How about give them scholarships to A&M instead? How about trying to figure out how to take money out of that so the tuition is lower? Something important.
Yes, that's my beef.
Anyways, hey, so
don't worry, Ernest.
No. This is all great because
this is what we do, Ernest. Just so you know.
Yeah, I mean, we just like ramble. It's like pretty nonsensical sometimes, but no, I mean, but that's why we appreciate. I mean, we're all about the charity on the show and just like having a good time and just talking a bunch of trash about tech. But Ernest, why don't you introduce yourself, man, and give us a little bit about EMQ Technologies, and then let's talk about what's hot in tech and what you guys are up to and how you guys are changing the world.
Sure. So I am Ernest Russell, technical content manager for EMQ. We are the world's #1 MQTT broker. And some of us know what that is in the audience. Some of us may not. So we can get into some of those details. But it's really interesting to be on the cutting edge of this technology. So I appreciate the opportunity to be here, to have some fun. So and definitely as a company, EMQ sends their thanks and their support for these kids. Let's like you said, let's make sure we close that digital divide. Let's help get them the opportunity to have the communication, the laptops. These are our future. So let's support them.
And keep in mind, it's equity divide, because I live in the digital divide.
Right.
I get SOS on my smartphone. It's like ridiculous, dude.
No, you live in the gap.
It really is. It is.
So tell us all about EMQ. What's it all about?
So we are very involved in many types of industries. How I usually explain it in a very simple way is we make dumb things smart. So information that's usually siloed in certain sensors, right? And so lately for us, the vehicle industry has been great for us and has been a great partnership with the growth of connected vehicles, having so many data points. We're talking sometimes millions of data points per second, right? That these car sensors are processing. And so with our technology, we're able to help filter all of that sensor data, help bring that into the cloud where all the magic happens, right? With AI and different graphical interfaces, right? That need to be created either for the business, for maintenance, or even for the customer. And I would say the best thing about EMQ and our product is really the scale, right? Because we actually have a free product. If you wanted to try our product right now, you say, hey, I got this home automation system I want to try out. You can actually download fully capable, MQTT broker and do all these things at home. But it's the scale that we help with. We have over 10 million vehicles out there that are using our messaging in one way or another. So to be able to process that type of device messaging at that scale and have sub-second messaging it is really the magic that we provide. So I'm excited to be part of it.
Ernest, no, that's a great background. So why is it important to have this protocol in place for vehicles? Is it something new? Is it old? Are these vehicles needing this for all these great applications that we're running? What's so important about having this now versus, 5 years ago? And what's the future look like?
Yeah, that's a good question, Stephanie. We're at a very pivotal moment because we're just getting into the adoption of connected vehicles, connected cars, right? And so right now we're in the middle of our transition. Like I know Steve is working on some connected car projects, right? There's so much data. They're almost becoming rolling data centers. There's so much data that are going through these vehicles. And so the next step right now is adopting the technology, scaling the technology to support the features that we need and the consumers want in these vehicles. But the next step and what MQTT, what that platform is going to allow, is not just the collection of that vehicle data, but when we start to connect to the infrastructure, that's going to be the real difference. And that's what MQTT can provide is a very simple, lightweight protocol that most sensors, most devices can easily translate to. And so it becomes that central method of communication, right? That everyone can understand, that works in tough environments where you're switching networks, you're driving through tunnels, you're driving cross country. Imagine how many networks you switch through driving from California to Texas or California to Atlanta even, right? That's a lot of networks. And so in the background, that's a lot of work that needs to be done in order to make sure you're not losing the connectivity, the messaging, the data that's driving the cars, and soon we'll also drive the infrastructure around them with traffic signals, charging infrastructure, all those things. I see your mind working, Pete. What you thinking about?
Oh, well, I was going to say, I mean, for folks, listeners that maybe aren't familiar with MQTT, we should probably talk about that a little bit. It's been around for a long time. It's been around for probably over 20 years as this kind of pub sub layer on top of TCP. Which is the thing that makes it, more reliable and more, flexible. And it's been used. I think it started more in the industrial space and IoT space. It's been around for a while. I know we had it on Azure IoT forever and AWS. And so what the interesting thing I think that you guys are kind of helping pioneer is taking this protocol that everyone kind of knows and understands and is comfortable with, and applying it to this new software-defined vehicle space, right? So now we're saying, let's take this existing protocol, pub sub protocol, and apply it to this new area, like you said, where a software-defined vehicle is this incredibly complex thing that has to do V to X, V to infrastructure, V to pedestrian, V to V, whatever, and using it in that context. And so it's interesting to see, in our world, we have these things that we've been using for decades, and they seem to always be finding new life. As the markets evolve, we take what we've developed and we continue to kind of innovate with it. And I think that was really interesting what you guys are doing.
Yes. Well said. And MQTT, I think it does deserve a little bit of background in that. Yes, it's been around for a while, and as you said, with the pub sub or publish subscribe architecture, it separates the client from the server now, right? And typically, as you said, this was over TCP/IP, meaning that you really needed a stable connection. You get into problems in TCP/IP when you're switching networks or your network is flapping, right? It's connecting, it's disconnecting. TCP/IP doesn't like that at all. And so one of the things that we did recently, and again with the automotive industry in mind, is we're the first MQTT broker to support MQTT over the QUIC protocol. And so basically we're able to layer that over UDP, essentially putting that data connection on a separate connection, your connection on a separate layer than your data. And so what that allows is it's able to switch networks seamlessly, again, without the client really caring or getting upset when those networks switch or disconnect. And we found that it's really been essential for that type of environments, for driving through several networks or remote networks, or even our cellular networks now. They're switching so much with 5G that you want a way to make sure that your clients are reliably connected, especially when you're getting those frequent bursts of information.
I know it's been important. I like everything that you guys are saying, and I've played around with EMQ's broker myself, especially in the building of leveraging digital twins, and when you got multiple protocols that are flying through, and we're trying to get the uniformity of delivery of the messages. And Lee Smith and Steve Reinert and I were talking about, going deeper in terms of that. But what I'm wondering about, and maybe the general, population doesn't understand it, because MQTT's been around for such a long time. Can you talk a bit about the migration from just regular MQTT to MQTT-SN? Because I think that's where the IoT devices kind of, gained the huge benefit.
Yes. Yeah. So thanks for that, Bill. So so for our audience, MQTT-SN is MQTT for sensor networks, right? So that's really it's an evolution of messaging that's specifically built around and for devices that either go to sleep, right? They disconnect and go to sleep for a while, wake back up, because these devices are usually battery operated, right? So they need to be able to go to sleep, wake up, send all their messages, right, and go back to sleep, right? And so we are able to support the traditional MQTT, MQTT-SN, and MQTT over QUIC, right? So these are all a mixture of different ways, depending on the client. And if we're talking about connected vehicles here, you're right. I think we're going to move more towards that efficiency of MQTT-SN, and again, and the ability to transverse over different protocols. And so we started as with the open source MQTT broker, but we've really layered so much value and so many features on top of that, and below that, because there's a layer of edge devices too, right? That we need to connect, and that's been a lot of the development that we've been doing in about the past year and a half. We have a new product that we call our edge compute platform. And so we manage that. We manage the service, not just from the broker level of sending and receiving your messages, but all the way down to the device level, right? The factor, whether that's the factory floor, sometimes that's embedded within the car. So we can manage that messaging from the device all the way to the cloud, and take that scale, take the operations out of the spectrum of things they already have to support.
When you said go back to sleep, it reminded me of a bedtime story from Samuel L. Jackson that I heard.
Yeah. Can we say that?
Here we go. Here we go.
It just popped in my head. It just couldn't help it, man. So you talked about QUIC, which is yet another wire protocol, which I think has been standardized now, and we're calling that HTTP 3. Didn't Google come up with that one? Is that they led the way with that? I think Google also created the stuff that led to HTTP2 as well. So for you folks keeping score at home, when you're doing quick and we keep hearing that word connection, all of a sudden it's connectionless, because this is a UDP protocol, which means there's not that same handshake like TCP/IP uses. Like right now on Zoom, we're using UDP because that's how the best way to do streaming and broadcasts and things like that, because it's lighter weight and it's tinier and it goes faster and there's a lot less negotiation and stuff happening.
Right. Yeah.
And so I think that's pretty cool, using your overall wire protocol on top of that protocol going. And then you're right, you talk about cars, when you talk about things that are outside and moving around, that means cellular. And you're going from tower to tower to tower, and lots of those handoffs are happening. Because yes, I'm working at Ericsson. Ericsson was the one who got all these cars in the United States. Gosh, before 2010, I think it was going through AT&T's network. Actually, I remember we started connecting cars, and initially it was little baby steps. It was just like, "Hey, I want Wi-Fi inside my car," and there's this LTE connection in the car, and then we would do Wi-Fi, kind of like when you buy a little Wi-Fi hockey puck thing. But of course, like everything else, we keep evolving, and now we're using all that technology to send telemetry about the health of the car in real time, so that you don't get surprised on the road, right? We know that's kind of as I love to say about IoT, without IoT, you're guessing, and with IoT, you're knowing. And so great technology like yours is helping make that connection and making sure we know what's going on with all these people cars. And you talked about thousands, all these data points. That's hard to keep track of. When I was at Hitachi, we put IoT edge computing on bullet trains in Japan, and we had 40,000 sensors on the bullet train just streaming data. It was crazy. That's good stuff.
Yeah.
Hey,
well, also,
Ernest,
go ahead, Steve.
So, Ernest, one of the questions I had for you was related to the idea that the sales cycle is so long, right? So stuff that we're doing, our projects are now looking at 3 to 4 years on the model, that's coming to market. Are you looking at your company as a greenfield or as a brownfield approach to the vehicle communications?
Well, I definitely agree with you there, where we're seeing long sales cycles, right? And especially in the automotive industry, right? So that's where how we're mediating that is we're involving ourselves more in POCs, making sure, because they get in this weird place where they know they want it, right? I want it. They know it works, but we don't quite have the budget right now, right? And so you get to that point where you have to prove it works before you have the money to make it work. Right. So we've been in this situation where we've really had to help set up the environment, set up the testing, simulate hundreds of thousands of devices connecting so that they can see the product, see the features, use the features, and that's been shortening the sales cycle some. But it just with dealing with these automotive giants, it takes a while to change directions and implement new technology.
But can your technology be put into existing vehicles on the road, or does it have to be in net new cars?
Thank you for allowing me to clarify that, because I think that is a pretty good misconception that whether it's a car, a ship, and I'll give you an example. One of our customers, Alpha Ori, they make smart ships. They do cargo shipping. right? And so they're not building new cargo ships, right? We are going in and we're retrofitting these older ships, these ships that have been around many years, and making them smart. And we could do the same thing for cars, but there is a limitation, Steve, in that it seems to go more towards the electrified vehicles because they have more sensors, more data. They're more prepared, better prepared to connect to an IT infrastructure, right? And could we monitor a combustion vehicle? Yeah, absolutely. But you just get more bang for your buck when we're talking connected vehicles.
So, I was curious, you mentioned the POCs and maybe some early commercial projects that you might have with these automakers. I assume that you're approaching, car manufacturers for your solution. What are the applications that are driving the requirements? Because, I think you've done a great job of outlining what technologies you guys are founding your products and services on. But as you go to the market, because this is a big question for the industry, right? Even V2X, I'm assuming cellular V2X, it's pretty nascent. But as you're talking to these prospects, if you will, what is it that we're looking at in terms of the applications that they're looking to run through your solutions?
Well, I'll break it down into three categories. I would say the first is one that we anticipated, and that is just the connected vehicle itself, getting the data that the vehicle is already collecting and getting that into the cloud. Okay. And so as we started doing that, some of our customers said, well, could you do the same thing for our factory? Right. So as we're building these, could we, the spray machines, the robotic arms, all these devices, could you build some kind of messaging, some kind of dashboard that can connect all this in real time also? Yes, we could. So we moved from now inside the vehicle to dog is fighting. We moved from inside of the vehicle to into the factory, right? And so now that's two use cases that we've seen is monitoring the vehicle, monitoring the factory itself, and then there's a third, and that is managing the charging infrastructure, right? And so again, that's why it tends to be more of the connected vehicles, because we can monitor usage, we can handle payments. We can reroute power for peak times or inclement weather. So the management of that chart. So now, again, in this one industry, you have these three major things that end up tying together. At some point, but again, MQTT becomes that protocol that's simple enough for and when we bring in, we can put together a device about the size of a Raspberry Pi. We can run the software. So when we talk about converting something that wasn't smart or wasn't able to communicate, we can run locally on say a Raspberry Pi. And now again, we've made something that was originally siloed, originally had all this data by itself. We're able to connect that to the cloud, to other devices, to a back-end system.
So I have a question. So is this, when I think about the connected vehicle itself, in the data that you're pushing to the cloud, is it primarily focused around the vehicle parts and equipment and maintenance and status of the vehicle itself? Or are we talking about the consumer side, the driver side, the safety, the assistance, other things that might change the experience of that driver, or infotainment? Where's the concentration? Or are there other things that are starting to enter the mix that you guys are starting to see kind of ramp up quickly?
We're seeing a very good mix. So one of the things that that are attractive to these manufacturers that have all these major products is they need a way to segment this data, right? Because at some point the data is going to the cloud, right? Maybe AWS, maybe Google Cloud, Microsoft Cloud, but their data is being processed in the cloud. Okay. And so instead of all these data points that we mentioned, you don't want to just dump all that data into the cloud, right? So one thing that we can do is smart filtering to be able to filter your messages based on your use cases. So as you mentioned, there may be a part of your let's say audience that wants to see speed, weight, how distance, GPS location, and so you can filter it and give that app or that person or that department just that data. They don't need to see 1,500 data points, right? They're interested. And so going back to that model of publish and subscribe, right? You're able to, for each client, each customer, you're able to filter based on the data that you need. And you can do that before the cloud, right? And so that ends up saving the enterprise lots of money and be able to only send the data that they need and be able to filter that.
So does that happen in the MQ? You have a thing called the MQTT platform. Is that where that filtering happens and massaging of the data or treatment of the data, or is it on endpoint?
We now, Leonard, we're actually doing both. Our broker does have the capability and an SQL based rules engine. So you can select what data that you want. But now again, with our ECP, our edge compute platform, or we're able to or edge cloud, platform. We're able to do that at the end user level too, or at the device level. So again, before that data goes into the cloud, you can run different filtering to only send what you want to the cloud, and then run additional filtering if needed in the cloud itself or on our broker itself also.
Okay. All right.
Cool.
You said SQL and the word select in the same sentence. So I applaud
you. Select, star, delete.
Hey, man, it's that old school stuff that still works, man.
Yeah.
Have to be all like crazy AI and doing all that
familiarity is an important thing in this world of technology.
Yeah.
Yes.
You think about why things like data lakes and Yarn and Hive and blah, 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 all that stuff that came out, for people to use, and they all dove in. But it turns out most people in IT go, yeah, I don't know what any of that is, but I know SQL.
Yeah.
Right.
It's like, yeah.
Well, I'm curious about the EV, the infrastructure side. You said that now that's kind of been an area of focus for you guys. Where are you seeing, like everyone's talked about us building out our electric charging infrastructure in the States, but what are you guys seeing? What's happening in that space? Because I feel like we went all hard and heavy after that, and there's been some companies that have not done well, and they just not going where they thought it was going to go. So what are you seeing in that space, and what's really driving the need to connect the infrastructure side for the EV charging sector?
Yeah, well, part of it is clean energy and compliance, right? And just like we want to support our kids for as far as technology, right? We want to make sure they still have an earth here, 50, 70, 200 years from now, right? And so many of that. Many of those use cases are stemmed around clean energy, managing power from distributed energy resources like solar power, wind turbines, to be able to do some cool stuff, like, for example, automatically trigger backup generators if you lose power, right? And so now these things are happening in real time. And when we talk about the factory floor, that's key. I'm going to say again is real time. So imagine the downtime, how much it costs, right? For these car manufacturers are rolling off, hundreds of thousands of cars, right? And so when that line stops, right, like it did for the strike recently, there's a lot of money lost. So they need to know in real time, this sprayer went down. This robotic arm has not responded. This sensor is not sensing. Right? So to be able to detect in real time, that is really key.
Yeah. I was going to just jump back to that energy grid comment you made, because I think that's such a ripe area for digital transformation. I mean, our energy infrastructure is probably 50 or 60 years old, basically, and it's designed around continuous energy, right? Yeah. That there's continuous flow of electricity, and we know that that's not the case. And so now we have all of these kind of, first of all, new ways of generating energy, like solar and wind and things like that are kind of a little lumpy. And we also have, this aging transmission infrastructure that needs to be ripped out and replaced. But we also have people generating their own energy, almost like they call it virtual power plants, right? So the whole energy thing is such an area where messaging and communication in real time is so critical. And it wasn't critical, back in the day. It was just, connect some big cables up and plug it in. And so that's an area where I think, as Ernest was saying, there's obviously environmental impacts to it, but just business impacts, just the impact of being able to provide the energy that's needed to power, we haven't talked about Sam Altman and OpenAI yet, but to power all of this crazy stuff that we're trying to get done, that grid needs to be smart and needs to be communicating continuously at all times from all these disparate things and pieces. And so that's where I see, you have obviously software defined vehicles and all the complexity there. But this whole energy grid thing too is another area where there needs to be a lot of kind of inter-piece communication going on around status and capabilities and what's happening in real time. So I think that's interesting that you guys are getting involved in that.
Well, I want to go back to the charging infrastructure again, because, where was I? I think I was at CES. I bumped into my friends at Keysight, and they were showing me some stuff related to the charging station management. And one of the things that they told me is that these stations have to be calibrated constantly, condition monitored. And so, I mean, I didn't hear that in your bit or your talk about how you guys are maybe involved with the charging infrastructure. But are you guys seeing any of that stuff? Because I mean, it's weird when you get under the hood of this infrastructure, even with that charging station, the complexity is immense. The optimizations that you need to do it kind of boggles your mind, even as much as the EV itself. You know what I'm saying? It's pretty crazy. So I don't know. Are you guys seeing anything like that? Because I was thinking, man, there's probably a huge opportunity there for, not only charging site optimization, but for let's say a cluster network of those, right? Because to Pete's point, these infrastructures, have to interface with our power grids, and that's layers on layers of complexity, right? And I don't think that's something that a lot of people appreciate.
Brownfield, yeah,
because they just think that, you set up a charging station and plug it in and plug your car in, and you're good. But these things
people don't realize that there's different levels of charging and different rates, and it's really way more involved.
Yes, and as the charging even the charging infrastructure that is in place today, as it was created, as it has grown, all of the future needs weren't always taken into thought, right? And so now we have some of these stations, right, that are islands out there, right? So it's just in the middle of nowhere. You got this basically small power station, but the power is in the connectivity, right? So when you're able to link 400, 500, 1,000 stations together, now you're able to do some cool things like move power between peak times. Again, if you have one service that generates that's generating more efficiently, you're able to actively switch. And so but I think it was mentioned here, the biggest thing and what we do and why we're embedded in so many different industries is because let's think about it. There's so many types of different solar powers. There's so many different types of generators, of PLCs, right? That control the movements of these panels and turbines. Right. Batteries. So the problem we're really, some of them are battery powered. So we got backup generators. All these things are talking a different language. And so all we're doing is being that glue to now we can say, okay, we got a million different languages we're talking here. Right. Let's combine that to a mutual basic language that everyone can understand. Right. And so the power is in the connection, just like our call today. The power is our connection together.
Yeah. Did you just say a basic language?
Oh my
God. Yes.
All right, Rob.
Do you live in a tech museum?
Yeah. Actually, right?
I do.
Oh, God.
It's a lot of artifacts.
I do have a lot of artifacts. Yes.
Yeah, some too laying around. Just not within arm's reach. I'm just surprised you didn't have to get out of your chair to go and find that thing. It's like
he's like
sitting right underneath your desk.
Let me go boot up my original compact luggable.
Oh man!
Show me your BlackBerry, Rob. Show me your BlackBerry and your Palm Pilot.
Hey, Marc, what's up? So yeah, Ernest, don't feel weird. This happens all the time. People pop in and pop out. It's the way it works.
By the way, speaking of EV charging, I saw a note about there's a gas station in the UK, or I guess a petrol station, a chain of petrol stations that is now adding EV charging into their mix, and which I think is the only way to go. The only way for it to be successful is for Chevron and Shell to take those 6 pumps and make 4 of them gas and 2 of them EV or something like that.
Not in the same stall, right? Yikes.
Well, I mean, obviously they're separated, but I mean, you gotta start turning these gas stations into EV charging stations. Otherwise, it's going out to the middle of nowhere, as Ernest was saying, to go charge your vehicle doesn't make any sense.
Well, as you were starting off with that, I was thinking, wow, this kind of sounds like a bad idea.
No, it's a good idea, but let's just keep the sparks away from the gas pumps.
Yeah, there's some safety involved, but
you're right. You're right. That's
he's saying because the locations are already there.
Yeah, and everyone knows to go there to refuel, and that's just the way it's going to be.
I think the problem is right now with those gas stations is we run in, get food, and get out. And now people are going to be waiting for this stuff to charge, so they need more things to do. We are so impatient, so we need activities while we're at the gas station, not just food.
Wait, are you saying that every gas station should be kind of like Wall Drug?
Yes.
Where there's a lot of activities when you're crossing the country or something like that,
Buc-ee's.
or a truck stop like Buc-ee's.
It's a TAM expansion opportunity for In-N-Out Burger, guys. Come on.
There you go. I fully
agree. Buc-ee's here has EV charging.
Buc-ee's, as always, Buc-ee's will lead the way.
Oh,
yes. Yes.
Buc-ee's for the
Absolutely, they will. No, but that makes sense. If we rewind the tape, a few decades prior to the electricity, EVs being hot, there was a moment in time where we were actually talking about hydrogen. And I know hydrogen's back again in discussion, but it was really hot a long time ago. And that was the discussion, is converting all the petrol stations into hydrogen stations and having that infrastructure to get hydrogen everywhere for hydrogen cars. Why did the hydrogen thing not work out? There was so much hype about that.
I think there's a cost issue with hydrogen that's just too expensive right now for it to be feasible. relative to natural
renewable
gas or real
yeah.
gas or electricity. So I think eventually, I mean, 10 years out, you'll see the cost of hydrogen. You'll see like edge data centers powered by hydrogen and
Really?
a bunch of other things. But yeah, I think so.
I
You'll
thought-
get there. It's just it's a cost issue. It's not a physics issue. It's an economic issue. I think it'll get there eventually, but not yet. It's very
So many
expensive.
people were like, it's the most abundant element in the universe.
Yeah, if you can
Right.
extract it out of water.
And then the output would just be water coming out of your tailpipe.
What
So
would the
it's
source
like-
be?
And water is a resource that we're already talking about. We are lacking.
Yeah.
So
Yeah.
And if you'll remember, Arnold Schwarzenegger converted his Humvee that he had back in the 90s
Oh,
or
the
whatever
Hummer,
to run on
yeah.
hydrogen
Hydrogen cell.
to try to get that going, and then it just didn't
Right.
go.
Yeah.
they didn't buy into it.
No.
Money.
Yeah.
We'll get there.
Yeah.
But
luckily,
yeah, all this stuff, like there's all these disparate pieces. I mean, to Ernest's point, disparate ways of creating energy now that we didn't have 10 years ago, and different pieces that need to be talking to each other for this stuff to work, whether it's in the vehicle or in the charging infrastructure, electrical infrastructure. And so, yeah, I'd say like no shortage of work to do in terms of getting these things to communicate in some way that makes sense.
The operative word, glue.
Glue.
Right?
Yes.
You guys are the glue. EMQ Technologies is a tech glue company.
There you
How's
go.
that?
I like it.
I like
like
it.
New
It's
tagline.
very
I love
sticky.
it.
you know what a lot of people
Oh my
don't
God.
realize. What a lot of people don't realize is in the early days when Facebook came out with their little messenger product for chat, they used MQTT to power their chat application.
Yes. Yes. You're out, and I'll give you some background on that, because I worked for, at the time it was a company called Limelight, and they had their CDN, and they had a real-time streaming service, right? And so the problem with most video and combining real-time chat is that you have that delay, right, Rob? Like you said, that's why we use UDP for things like Zoom, but that doesn't scale well to hundreds of thousands of people, right? So you want, in order to have that low latency, we used MQTT to power our chat also so you had sub-second video, but now you have that sub-second messaging to go with it. So you can do cool things like online gambling. It really creates that interaction that we want now. So again, it can be used in so many different ways.
There you go. You're powering Las Vegas with online gambling via MQTT.
There you go.
Yes.
See, you add that to the gas station wait while you're charging your vehicle.
Yes,
That's it.
absolutely. We go to CES, we're searching for your booth, and it turns out it's just all around us in the casinos already. Lots of devices to connect that are electronic these days. Send data. We've been sending data back and forth from machines forever, and we've rolled our own wire protocols over the years and data formats and things. I can't tell you how many homegrown things there are out there. And I love it when people talk about standards in IoT and stuff like that. And I was like, there's a lot of standards.
Right. No shortage of standards.
Which one do you want to subscribe to?
Right. Pick one. And yeah, especially when you go into that industrial world in factories, there's hundreds of other standards. The difference, though, and I always like to say this, is it not only does it need to be a standard, like an open standard, it needs to be ubiquitous in its use. And so there's a reason why sometimes there'll be a standard that maybe is not nearly as efficient or as good as MQTT, but it might be the most ubiquitous thing on the planet, which would be HTTP REST, right? Whenever I see like yearly stats of which wire protocol is leading for IoT, REST and MQTT are always neck and neck. It doesn't mean that REST is as good as MQTT, but it's the most pervasive way the whole planet communicates already.
Yes.
And so back to that familiarity thing, right?
Yeah.
And we had this whole API revolution in the enterprise, and that's all based on REST, right? And so that's why we still see it in devices. Doesn't mean it's the best thing. It's just everywhere.
Well, we were
And
always using APIs. People just didn't know it.
Yeah. Well, APIs used to mean something in your code on the app you were writing. Interfaces. And
or
then
interfaces.
we went from Corba to DCOM.
Oh my God, you're making me feel old.
REST to, stuff like that, right?
Yeah.
I remember building a supercomputer with Windows T machines using DCOM to have them all talk to each other.
All right, you're old. I don't know what you're trying to prove there, dude.
I am not old.
Oh my gosh.
Oh my God, it's so funny. But hey, we're almost up on time. So, there's no way in hell we can have Marc pop up in this whole Brady Bunch like grid here and not say anything. So, Marc, want to say something?
Where are you, Marc?
Can you hear me well?
No,
yes.
But you're going to talk anyways.
No?
You sound like crap.
So, this Chinese headset is not working well. Anyway, I'm super glad to have this episode because, I see MQTT making it happen in the years, as Rob said. So the IoT, finally, or a niche of IoT is getting into MQTT, and that's a success story that we can explain. So that's super cool. That's why I wanted to connect at least for 5-10 minutes.
Oh, that's cool. Well, hopefully at some point in the future, ChatGPT-X can transcribe what he just said. But I think we got the spirit of what you were trying to share there. But hey, Ernest, I think we got to wrap up here. But it was wonderful having you on. It's wonderful to engage with EMQ Technologies. We fully and heartily, is that even a word? Appreciate the donation. Okay, to elevate our kids. Remember, everyone, www.elevateourkids.org. Please make a donation. We have a donation drive, and I'm going to shut up. And who wants to take us out?
I think Stephanie should take us out.
Yeah. We're going to take us out. All right. Well, we appreciate you, Ernest, again. I think there's a lot to be said for tech companies that actually talk the talk. We have a lot of friends and executives that we all work with all the time that just we're asking and pleading for you guys to donate and be a part of this, and we'll get you on as well. So elevateourkids.org, and also to listen to all of our episodes, check out iotcoffeetalk.com. We have our LinkedIn page set up, or you can just plug in the URL and it'll take you straight to our YouTube page. So you can check out all of our 90 plus episodes now.
100 and I think there's 185 now.
It's getting up there. So check us out. And essentially, we're on the interweb, the web 3.0. We're everywhere. And we're also on all your streaming channels. Ask Rob all about that because he's getting a lot of those episodes out there for us. Thank you.
Thank you so much.
Thank you.
Yeah.
Happy Thanksgiving, everyone.
Take care, Ernest. Thank you.
Thanks.
Thank you. And
Talk to you
happy
soon.
Thanksgiving.
Bye, Marc.
Motor in my shirt.